In this lesson, we're going to learn about parallel and perpendicular lines. The objective of the lesson is to relate parallel and perpendicular lines. First theorem says that if two lines are parallel to the same line, then they are parallel to each other. So in this diagram, we have lines A and B are parallel to each other, and lines B and C are parallel to each other. So that means that A and C have to be parallel. So if we write this as an if-then statement, we can say if A is parallel to B and B is parallel to C, then A has to be parallel to C. This is similar to a transitive property for parallel lines. So just like inequality, if A is equal to B and B is equal to C, then A is equal to C. So this is very similar property for parallel lines. In the next theorem, it states that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So in the diagram, we have lines M and T are perpendicular to each other. So if M is perpendicular to T, and we also have line N is perpendicular to T as well. So line N is also perpendicular to line T. Then we can conclude that line M is parallel to line N. In the third theorem in this lesson, it actually has a name. It's perpendicular transversal theorem is the name that you can call it. And it states that in a plane, if a line is perpendicular to one of two parallel lines, then it's also going to be perpendicular to the other one. So in this diagram, we have line N that's perpendicular to line L. And so if line N is perpendicular to line L, and we know that line L is parallel to M, then we can conclude that N is also perpendicular to M. So let's look at the couple of problems on the right side of the page. In problem 1, we're solving a problem with parallel lines, and it asks what is the relationship between segments AB and segment CD, and you have to explain your reasoning for stating the relationship between them. So let's look at some of the angles that we have in the diagram. We have the measure of angle ABC. So we have the measure of angle ABC by the angle addition postulate. It's going to be the measure of angle ABD, which is 68, plus the measure of angle DBC. So we can substitute from the diagram into this statement, and we have 68 plus 22, and that's equal to 90. So angle ABC is a right angle, and we can also state that segment AB is perpendicular to segment BC. That's by the definition of a right angle and by the definition of perpendicular lines. We can make those statements. Now the next angles that we're going to look at, change colors. we're going to look at the measure of angle BCD. So BCD, measure of angle BCD. Once again, the angle addition postulate. It's going to be the measure of angle BCA, which is the 35-degree angle, plus the measure of angle ACD, which is the 55-degree angle. So let's substitute for measure of angle BCA is 35, plus the measure of angle ACD is 55, and that also equals 90. So we can make the statement that angle BCD is a right angle, by definition of a right angle, and we can also say that segment BC is perpendicular to segment CD, by the definition of perpendicular lines. So we can conclude that segment AB is parallel to segment CD because both are perpendicular to BC. In problem 2, we're proving a relationship between two lines. It states that in a plane, line C is perpendicular to line B, and line B is also perpendicular to line D, and that D is perpendicular to A. And it's just asking you to prove that line C is parallel to line D. So let's see what we have to start with. Let's start with some of the information that we're given. So we can write a paragraph on this one. We know that line C is perpendicular to line B. That's given. So lines C and B form right angle by the definition of perpendicular lines. B is perpendicular to D is also given. So lines B and D form right angles by the definition of a right angle. Now we also know that all right angles are congruent. By the right angle congruence theorem that we learned in the last unit. And so since these right angles are corresponding angles that are congruent, so they're corresponding congruent angles, we can say that C is parallel to D by the corresponding angles converse.